Okay, team. In this video, we're going to talk about how virtualization allows us to handle virtual machines as objects. So virtual machines are created and managed by software. And the hypervisor keeps track of virtual machine resources. So the hypervisor keeps track of the CPU state of the virtual machine, the memory that was allocated to the virtual machine, and also the state of the virtual input-output devices that the virtual machine is using. And even if there is some state that is outside of the virtual machine, say in storage devices, which might be local disks or remote storage over the network, the hypervisor can still keep track of these information. And this allows us to turn virtual machines into a set of bytes. And turning a virtual machine into a set of bytes allows us to migrate the virtual machine. So we stop the virtual machine, we turn it into a set of bytes, and then we move the data to a different server. And then we restart the virtual machine on a second server. So we removed the virtual machine from server A and restarted it as it was before, but now on a different server B. So virtual machine migration has many benefits. First, it allows us to sidestep server failures. Say if a server has a disk that we know is going bad, we can stop the virtual machines on that server, turn the server down, and then restart the virtual machines on a different server. Virtual machine migration also allows us to control load on servers. So if a server is overloaded, we can remove virtual machines from that server and restart them on a different server. And if a server is underutilized, so if it has only one virtual machine running on it, for example, we can move this virtual machine to another server and then turn the server down, for example, to save power. Migration also allows us to perform load balancing. So consider the case where we have two servers. So the server 1 running two virtual machines and server 2 also running two virtual machines, but the virtual machines on server 1 use a lot of CPU and not much else. And the virtual machines on server 2 use a lot of network. So server 1 will be struggling for CPU because everyone is trying to use its CPU, while server 2 has idle CPU capacity. There's not much CPU work going on in server 2. And vice versa. So server 2 will be struggling for network bandwidth, while server 1 has spare network bandwidth because there's not a lot of network communication going on in server 1. So we can use migration to balance load across these two servers. So we can move VM2 to server 2 and VM3 to server 1, and this will make it so that both servers have full utilization of their CPU, full utilization of their network, and overall we get more work done from the same two servers. And finally, migration also allows us to improve traffic patterns inside a data center. For example, the cloud provider can migrate a tenant's VMs so that they all run on the same pod and thus traffic remains local. Okay, but unfortunately, the way in which I just explained migration, stopping the VM, migrating the VM, and then restarting it on a second server would interrupt network communication. And this is not okay. For example, if a remote client over the internet is accessing an application running on a virtual machine, and the cloud provider decides to migrate this virtual machine and stops it, the client won't be able to communicate with the application anymore. So the client will just, freeze up and it might give up on this connection. So the client would experience a failure. So depending on the application, this is, undesirable, and depending on the application, this is unacceptable. So we can't just stop a VM for a long time and let remote clients experience failures. And also, if we stop the VM for a long time, tenants would be able to perceive migrations, so it would not be transparent. So to avoid this, engineers have developed live migration. So live migration keeps the VM running for most of the migration, and it happens in 3 steps. The first step is called pre-copy, where we're going to copy all the memory allocated to the VM to a different server. So here we are migrating VM1 that is running on server 1 to server 2. In the pre-copy stage, we're going to copy all of the memory from VM1 to server 2. And this will take most of the time for the migration, particularly if the VM is very large, if it has a lot of memory. So we're going to copy this data to the second server. And after the pre-copy stage is done, after we have copied all of the memory, then we're going to freeze VM1. And now we're going to finish the migration. So one of the things that might have happened while we were in step 1 doing the pre-copy is that the memory in VM1 might have changed. For example, VM1 might have done some modifications in memory, edited a figure, saved some new data. So we're gonna have to synchronize this memory again. So we're gonna copy some of the data again to update the copy that we have on server 2. So we're gonna copy this over the network, and now the memory is exactly the same because the VM is stopped, so its memory is no longer changing. And then in the last stage, we're going to synchronize the volatile state from server 1 to server 2. So we're going to copy the state of the CPU that the VM had before we stopped it, and we're going to copy the state of the input-output devices. And then finally, we're going to start VM1 on server 2, and we have completed the migration. So the good news about this is that most of the migration takes place in the pre-copy stage, while the VM is still running on the first server. After we have copied the memory of the VM to the second server, we're going to stop it and then complete the migration pretty fast. So we're going to copy whatever has changed, which is fast, and there are mechanisms that the hypervisor can use to track what memory has changed. So we're going to copy this changed memory to the second server, and then finally we're going to synchronize the volatile state, which is also not very large. So stage 2 and stage 3 usually run fast enough that applications don't break while we are finishing the migration. And this allows us to gather all the data of a virtual machine into a set of bytes and then decide what we're going to do with it.